So I found a video to make talking about the rock cycle a little bit more interesting. We'll watch pretty much the whole thing, but I will pause it a couple times to add some notes.
I bet you thought rocks are just rocks, right? Nope. There are three major types of rocks: sedimentary, igneous, and metamorphic. But the coolest thing about rocks is that each one has the ability to change into the other kind.
Huh? How is that possible? Sedimentary, metamorphic, and igneous rocks change into each other in a process we call the rock cycle. No, not that kind of rock. This kind of rock. Yeah, that's more like it. The first type of rock we'll talk about is sedimentary. On the surface of the Earth, wind and water break down rock into tiny pieces. Those pieces might collect in a riverbed, on a floodplain, be swept into sand dunes, or collect on the ground. Over time, layers of these rock fragments build up and start to weigh down on one another. Eventually, they get fused together to form sedimentary rocks. The cool thing is that if you look closely, you can still see pieces of the original rocks or sediment that were bound together.
Let's do a demo. For our rocks, we're going to use jelly beans. Each flavor of jelly bean represents a rock or mineral that has been broken down by wind and water through a process called erosion. We put our jelly beans in this bowl and add some honey and cornstarch. They're the bonding agents to hold our pieces together, kind of like glue for rocks. A little time and pressure has turned our jelly bean pieces of sediment into a brand new rock.
So what happens if you apply both heat and pressure?
All right, I'm going to pause it there really quickly. It shows under sedimentary rock, the process of erosion. They actually describe the entire process, but it's not just erosion. The process that breaks down the little rock pieces is actually weathering, and that can be done through physical weathering, or mechanical weathering, where the pieces of the rocks are actually broken up by things like temperature change, wind, water, or the roots of biological agents like trees or lichen. And then there's also chemical weathering, where things like acid will react with the chemicals making up the minerals in the rocks and actually break down the rocks that way. So that's weathering, the breaking down of the rocks into smaller bits or sediments. And then what erosion does is actually move those bits from one area to another, usually through wind, or more commonly water in the form of running water, liquid water, or through ice, as in glaciers. Then those little sediments are finally deposited through deposition in an area where it can then build up to form a sedimentary rock. So this is simplified a little bit, but it's important that you write weathering and erosion down as processes that produce sedimentary rock, not just, or actually those are processes that produce sediments, and then cementation, where just minerals are going to help glue those little sediments together, is what actually forms the sedimentary rock.
It becomes a metamorphic rock. Metamorphic rock may form by friction of the Earth's shifting crust, pressure deep within the Earth, or even radioactive decay. The heat and pressure cause the rock structure to change, so it takes on a new form. Even though it's changed, you can often still see structures of its original components.
Let's take our sedimentary jelly bean rock and turn it into a metamorphic one with heat and pressure. To add pressure, we'll put this heavy pot on top. For heat, we'll stick it in the oven for about 30 minutes. After it's cooled, you can see how our jelly bean rock has formed a more solid unit. However, you can still see the individual pieces of candy, but the structure has fundamentally changed.
Another really important thing about the process that forms metamorphic rock, heat and pressure are those processes, but it doesn't actually completely melt the rock. Just like you can still see the individual chunks that were jelly beans, the the pieces of rocks are still there. They have been changed, but it hasn't completely melted.
The third type of rock in the rock cycle is igneous. When rocks get superheated deep within the earth, they melt and form a liquid called magma. If magma rises to the surface or moves up in the earth's crust, it begins to cool.
Okay, I just wanted to back up a little bit here because we're seeing two kind of cool things here. The magma that's rising all the way to the surface is going to form an extrusive igneous rock because it is cooling at the surface. It cools relatively quickly at that point and tends to make rocks with very, very small crystals. Not a big deal to remember, but that's extrusive igneous rock. And then rock can also form when magma cools within the earth, which is happening in the case on the bottom left here, and that's called intrusive igneous rock. And that magma is going to cool a lot slower, and so rocks that have formed this way usually have much larger crystals. So if you have like a granite countertop with lots of specks of different colors, that was probably formed under the earth, so it would be considered intrusive igneous rocks. So all of Earth's crust, all new rocks are formed as igneous rocks. Okay, we'll go back to the video.
Moves up in the Earth's crust, it begins to cool. Igneous rocks have a uniform structure throughout, but will have different properties depending on whether they cooled on the Earth's surface or within the crust.
To turn our jelly bean metamorphic rock into an igneous rock, we're going to melt it in this pot of boiling water. When our rock has cooled, you can see how all the different pieces combine to make an igneous rock with uniform structure throughout. Pretty cool, huh?
But this is only part of the story. We showed you one path through the rock cycle, but really any rock can go from one type to another. For example, igneous rocks can turn into either metamorphic or sedimentary. And metamorphic rocks don't have to become igneous rocks. They can be broken down again and become sedimentary. Or the sedimentary rocks can get pushed deep within the earth to form igneous. See, all of the rock types are connected, making a cycle that never ends. The end.
All right, I think that's it. Hopefully you took some notes on that. Also make sure to do your reading on this section.